Guys, we are back at it. Welcome back to Soft Spoken Scientists. Let's pick up where we left off. So we have write 6,300,000 in scientific notation. First things first, ask yourself, where is the invisible decimal point that they don't really talk about? Right here, at the end of the number, because they didn't put one in there. And, it's like $25, $250, right? Where would the decimal point be if I had $250? At the end right here. That would represent that I have no sense. All right? So I'm going to start here because I know in my head 6.3 is less than 10, but it is greater than 1, so it does meet the requirement. So 1, 2, 3, 4, 5, 6. So 6.3, check, times 10 to the 6th. This is in scientific notation. We're going to move on to converting a scientific notation to standard form. So convert 3.2 times 10 to the negative 4th to standard form. Okay, so just add a bunch of invisible zeros, and you can add some in the front if you want to. So I have it raised to the negative 4th. When something's raised to the negative, would it be having the decimal point move to the left or right? To the left. Okay, so I'm going to move this decimal point to the left. 1, 2, 3, 4 times, right? So I got 0.00032. That's that. Okay, what about 4.80 times 10 to the 5th if we want it in standard form? So let's add a bunch of zeros. And are we going to move it to the left or to the right? Well, this is a positive number, so I'm thinking right. So let's move it 5 times to the right. 1, 2, 3, 4, 5. So it would be, add your commas in purple for every 3 numbers. So 1, 2, 3, comma. And I'm not going to put a comma right there. That would make no sense. So it'd be 480,000. This is really important for our next topic we're doing. All non-zero digits are significant when we're discussing significant figures. They're non-zero. Any number that's non-zero is significant. So 347 has 3 sig figs. 3, 4, and 7. Rule number 2. Leading zeros do not count for anything. They're not significant figures. So 0.00. Those are leading zeros. They're leading me to the non-zero digit. They do not count for anything. So the only sig figs I have are 4 and 5, which is 2. So 2 significant figures. Look at number 3. Zeros between non-zero digits do count. Example, 1,002, that's 4 significant figures. 1, 2, 3, 4. The trailing zeros, for number 4, only count if a decimal is shown. So with 2.50, it would count because the decimal is shown after. So look, 1, 2, 3, 3 sig figs. How many significant figures are in 0.0081? You're a leading zero, you don't count. You're a leading zero, you don't count. You're also another leading zero, so just 8 and 1. That's 2 significant figures. Only 8 and 1 matter. 2. How many significant figures are in 2.30? Okay, let's think about this. Trailing zero counts because decimal is shown. So 1, 2, 3. So 3. How many significant figures are shown in 500? There is no decimal point that they deliberately made us see that is visible. Okay, because I know I told you all that there's a decimal point right here. That is true, but they didn't write it. If they didn't write it, these zeros are irrelevant. So it's just one significant figure. No decimal, trailing zeros, ambiguous. All right, let's talk about this one. How many significant figures are shown here? So let's check this out. We have a leading zero, we have a leading zero. So we just got to focus on what is happening after the decimal point. So zeros between and after decimal do count as sig figs. So 1, 2, 3, 4. So 4. So let's talk about this one. Part 4 of sig figs and calculations. Multiply, and when you divide, you want the fewest sig figs. When you add and subtract, you want the fewest decimal places. Let's try this one out. You got 2.5 times 3.42. How many significant figures are here? 2 sig figs. How many are here? They're all non-zero digits, so 3. So I did on my calculator 2.5 times 3.42. I got 8.55. So here's the deal. I need 2 sig figs. I want the lowest amount possible. And I'm at 8.5, and my neighbor is also a 5. And a 5 and above, I'm going to give it a shove. So it's 8.6. And I want to just clarify, did that make sense? So if you had, let's say, 6.61, and you want to write it in 2 sig figs, do you guys know how to do that? What would it be? Or no, yeah, let's try 6.61. It would just be 6.6. What if I told you we have 6.51 and you want to write it in 2 significant figures? What do you guys think you would do? Guess what? It's 6.5. Now, I know I said 5 and above, you give it a shove, right? But here's the thing. You only do that if your neighbor is a 5 or above. See, they're not greater. This 5, its neighbor is a 1. So it's just 6.5. It's not 6.6. All right, just want to clear that up with you guys. Okay? So let's try this one. Calculate 27.4 minus 20.0. So for a problem like this, what we want to do is say, okay, where has the least decimal places? 0.4, one number after the decimal point, and then there's a 0, one number after the decimal point. So check this out. We are going to do, we want to get an answer with one number after the decimal point. So if I plug this in my calculator, I'm going to get 7.4. That's it. If you can do these problems cleanly, you're in great shape for general chemistry. Next up, we'll use these skills with dimensional analysis and real chemistry equations. Thank you guys for all of your love and support, and please hit that like button. Please hit that subscribe button. I love when y'all do that, and just know STEM is for everybody, especially you.